All right, new question. New question, but we're going to begin in the same way every time. We're going to read the question sentence first to understand the goal, then we'll read that information. So here it says, how many laps around the park is that? So again, whoops, right here. So it says again, how many laps around the park is that? So to find out how many laps that is, well, we need more information. So here it says, a rectangular park is 100 meters by 50 meters. A walker travels 1,500 meters along the edge. Okay, so when we have this rectangular park, we see that this person who's walking goes around and around and around and around and around until they hit 1,500 meters. So we need to know how many laps is that. So to figure that out, we need to understand how long one lap is. And that's going to be one perimeter, going around one time. The perimeter is going to be double the length plus double the width. And this is going to be straightforward here because double 100 and double 50, again, very straightforward because that's going to be 200 plus 100, giving us 300. So what we know here is that each lap, every time we go around this park once, that's going to be 300 meters. My party people, how many times do we need to go another lap, another 300? How many times can we go around until we reach 1,500? If you don't know that off the top of your head, that's fine because this is division. You take your total and you divide by how long each lap is. And so effectively what you have is the zeros there cancel out. The zeros here cancel out, and we have 15 divided by 3. My party people, I think we all know what that is. 15 divided by 3 is 5. So we can complete 5 laps right here, answer choice B, to reach 1,500 meters. And there we go. All right, next question here. So as always, we read the question first. That's basic strategy. And it says, what is the total elapsed time? And in parentheses, it says, including the rest period that we took. Okay, sounds good. Let's highlight that. What is the total elapsed time? So before we begin, take this mental note. Because it says we're looking for the total elapsed time, so how much total time was taken, we're going to look at all of the situations and we're going to add their times together. That's what we're going to do. Before I continue, do you agree with that idea? Right on. So before we continue, before we add up these times, let's first go ahead and find the times. Let's find those individual times. So read along with me. Let me go ahead and get this red highlight out of the way first, and let me show you. We have first that this bus travels 90 miles at 45 miles per hour. Then it rests for a quarter hour, and then goes 45 miles at 60 miles per hour. My party people, how many different situations are we dealing with here? How many different events did I highlight? How many events? 3. Exactly. There are 3 events that we have to add up the times for. However, do you notice that for the red situation, the first situation, we have distance and we have rate? Do we have the time, everybody? Or can we find it? Yeah, we can find it. We can absolutely find it using our formula. Let's write this in red. Here's the first part. We have distance equals rate times time. I'm going to plug in 90 miles for the distance, plug in 45 miles per hour for the rate, and then we have our time right there. To get the time by itself, we're going to divide, because remember, whenever we're looking for distance, we'll multiply. When we're looking for anything else, the rate or the time, we will divide. So we'll divide both sides by that 45, nice and easy on both sides. And we see that we cancel out on the right side, leaving us with 90 divided by 45. Somebody help me out. What's that going to be? 90 divided by 45? Yeah, that is 2 hours. So right there, everyone, right there, that is the first time period. Is the final answer 2 hours? No, it's not. It is not. It is just the time for that first part of the trip. Now, when we take into account the second part of the trip, well, the second part, we rested. We rested and they gave us the time, 0.25 hours. So I'm done with part 2. I'm good. Because again, it says including the rest. So we want to include that 0.25 hours. Now, number 3, we'll look at situation number 3. And situation number 3 is represented as 45 miles, which is a distance, 60 miles per hour, which is a rate. So I'm not given the time, but I can absolutely find the time. I can figure out what that is. So here, my distance is 45 miles. My rate is 60 miles per hour, and that's multiplied by time. If you switched these up, if you accidentally swapped out the 60 and 45, and you thought that the distance was 60, you would have gotten answer choice D, and that would have been wrong. That would have been wrong. Let me continue here and show you how this is wrong and how it actually would be B. Let me show you here. So I'll divide both sides by 60. Once we do, cancels on the right, but notice that we are dividing by 60. And once we do that, we'll do 60 going into 45. And let's get it done. So 60 doesn't go into 45, so we have to use decimals. We have to use some extra zeros. And so from here, 60 goes into 450. That will be 7 times. 7 times 60 is 420, leaving us with 30 remaining. And we'll drop the 0 here, giving us 300. 60 goes into 300, a total of 5 times, and that's clean. It's a clean 5 times because 60 times 5 is 300, giving us no remainder. So what that means is the time that we took on part 3, right over here, is 0.75 hours. So now we can finalize this solution. Now we can do that because all we have to do now is add up each of these individual times. And when we do that, 2 plus 2 plus 0.25 is 2.25. Then we add the final 0.75 remaining, and that's going to give us a total of 3 hours. That's the grand total. Boom. And that's why the correct answer is B. Again, answer choice B and not answer choice D. D would have been achieved, again, by dividing the 60 by 45 and not the other way around. And that's why it's so important to take the numbers for what they are and not try to fit them forcefully into some convenient scenario because it feels good. Let's tackle this next one here. So the problem reads and instructs us to evaluate this expression. The expression is negative 3x squared plus 4x minus 8, where x is equal to 2. Sounds good. So I'll replace x with 2 and see what I can do from there. We have negative 3 multiplied by 2, and that 2 is squared. Then we have plus 4x, where x will be replaced with 2 again. And then we have minus 8. So from here, we end up going with 2 squared, which is 2 times 2, and that'll be 4. Then we have 4 times 2, which is 8 over there, and then minus 8. So I notice immediately that I can cancel these out, and that's exactly what I'll do. I'll mark those for cancellation, nice and easy. And then the last step I need to take is just doing negative 3 multiplied by 4. 3 times 4 is 12, and then a positive multiplied by a negative ends up leaving it as a negative. And there we are. The correct answer here is answer choice B, negative 12. And there we are.